Good morning and welcome everyone on this particular talk where we're going to talk about how one of our customer, View360, uses Azure platform to build their IoT solution. So we're going to talk about end-to-end solutions, data coming from sensors and how we actually moving this data across the cloud and what kind of analytics that we are doing and what are the challenges that we come across when we are implementing that project with the customers and how we can overcome with those challenges, right? My name is Sudhir. I work as a senior technical evangelist with Microsoft developer experience team in India. So let me just move on to my next slide. So before I go ahead and get started and talk about the technical capabilities of our platform or what are the challenges that we have faced, let me just give you some background about View360 technologies. So the View360 technology company is basically based out in Hyderabad city in India. And they are basically, IT outsourcing and providing consulting to various firms. Apart from that, they have various monitoring solutions. For example, telecom tower monitoring solutions, IT infrastructure monitoring solutions. They also have remote asset monitoring solutions, and so on and so forth. So the telecom tower monitoring solution, which they also know called as View360, it's basically meant for monitoring the telecom tower operations, telecom switching, and transmission events for the management, right? So the whole idea of this particular solution is basically to, to monitor, automate the entire process to basically factor the real-time issues. For example, power instability, network instability, right? Human dependencies, and as well as operational constraints in the network, right? What all technologies involved in this particular solution? Obviously, Azure is there, and we're going to talk about more in details what all services that we have implemented and why it's so. And we're also going to talk about what the existing architecture that they were following. So that's their earlier architecture before we get into their office. So what they were doing is they have various sensors which basically connects to the gateway. And they have basically 2 VMs running on the AWS cloud, where one instance acts as a listener instance. So what they do is, in that particular VM, they open a port where the gateway will send all the events. Then they have another instance running where they have a SQL Server DB. They have their web application running, and they have a couple of Windows services running into it. Why they were running Windows Windows service in that is because the Windows instance basically talking to that port which is open on the listener instance to watch, if there is any events are coming up. So as soon as the event comes up, they basically take that event, process it, and based on the various threshold, either they will send it as an SMS to the supervisors, or they basically show that report into the web application so that user can actually look into what's happening in the field, right? Now, obviously, there were some problems and some challenges that they were facing when we get started talking to them. So one of the challenges is with the security, right? Because they have this VM running, they have this port open, so anybody can actually go ahead and send the data to that particular instance, right, which is not secure enough. They don't have any security for devices, so all the devices are basically configured to send the events to all the VMs over there, right? Scalability, which is another concern. So as they are growing, their big concern again, how we can actually go ahead and scale it. Whether we can scale up by adding more hardware, in terms of RAMs or in terms of cores, or can we go ahead and scale out, right? Can we put multiple machines, right? And let scalability go out and serve the purpose, right? The other challenge that they have, the event processing. So it's not only about the code that they have written to receive the events, process it, but also how they can actually go ahead and make the logs available so that if something goes wrong, they can actually go ahead and look into the logs information. So which is taking a lot of time for them to understand what's happening and make them more scalable. The visualization component, it's very less for them because they are using the Visual Studio environment, and they are designing their own controls, which take a longer time for them. and as well as the report running. So right now, they are showing the reports in a web instance. But going forward, what they want to do is they want to enable their users to look into the data on their mobile devices or maybe on the tablets as well, right? So when we get into the talk with them, we basically lie down some basic architecture, right? So the story starts with the sensors, right? So, and then the data goes to the gateway. Now, View360 are basically using the embedded C programming NSIM 900A, which is a 2G edge network, to send the data to the cloud, right? They have two versions of their device, which is the gateway. One is, the first version is 2-voltage battery measurement circuit, which basically have the various sensors wired into the microcontroller, right? The another version that they have is a 3-voltage measurement battery measurement circuit, which basically have a couple of sensors, like your temperature sensors, door sensors, smoke sensors, which are either, some of them are connected through the wire, and most of them are connected wirelessly through the Zigbee protocol, right? Now, once they have the data, the first thing is that they're going to do is the device registration, right? So they don't want anybody to send the data to their IoT hub, right? So before they're going to go ahead and do that, they basically register the device onto the IoT hub to enable the authentication. So now, once the device registration happens, they can actually go ahead and send the data to the IoT hub, right? Now, we face some couple of challenges over here, okay? The first challenge that we face is basically these devices that they have on the field. We tested with those devices, and we figured out, it's not able to communicate to the IoT hub, right? So what we do is, I'll show you the command that we use to send the data. Let me just go back to my screen over here. And just give me 1 minute. I'll just say, go back to my browser. And let me go. Right. All right. So these are the commands that we were using to send the data to the IoT hub, right? So we are using the HTTPS protocol over here to send the data to the cloud. Now, we could have used the IoT hub SDK over here, but the challenge with them is all these devices are battery-operated devices. So they don't want to put extra memory footprint onto the device. So as soon as they install SDK, there are some space which will be consumed, right? So that's the one thing. And why it's a challenge for them? Because whenever the network connectivity is not there on the remote area, what they do is they basically store the data locally in the device itself, so that as soon as the network comes available or somebody reach to the device with the mobile network, they start sending data to the cloud, right? So they don't want to put more memory print onto the device, and that's the reason we haven't installed any SDK over there. We use HTTPS protocol over there to send to the data over there, right? Now, this code was not working initially, so what we figured out is, their firmware is not upgraded. So we talked to their OEM and asked them to upgrade the firmware on the devices itself, and as soon as they did that, we were able to communicate to the IoT hub, right? The other thing that we have did is, for them, is basically we write a small piece of code over here, right, which basically generates the token, right? So whenever you create a device onto the IoT hub, right, it generates a key for that, for the authentication purposes. So whenever you're going to send any communication to your IoT hub, you're going to send your device ID and the key as well for the authentication purpose, right? Now, we don't want to do that. We don't want to send that over the network. So what we did is we basically write a simple functions. What it does is it basically generates a token. And if you see string base address, it has the address where it's going to send the data with the device ID. And then we basically, if you look at the byte data, the next second line from there, it basically encoding the device key as well. And this entire thing, we're basically creating a token. Whenever we're going to communicate to the IoT hub, we're going to send this token to the cloud rather than sending the plain device ID and the device key over the internet, right? Now, let me just come back over here on my slides. Come over here. OK. So the next thing is we are getting the data. So now we need to process this data, right? So we basically go ahead and use the Azure Stream Analytics over here. Now, some of the computation that they do onto the device or the edge level itself, and which is, what they do is they basically, any event that comes in, they basically checks if this any values gets changed from the previous event. If the value gets changed, then they send to the IoT hub. If not, they wait till maximum 3 minutes to 5 minutes, depending on the business requirements. And then after 3 minutes, it's whether it's a duplicate event or it's the same event or not, they will send this to the IoT hub, right? So this is a continuous stream of data which is coming up, and that's why we use Azure Stream Analytics to process the data, right? So the challenge that we faced over here is because in their earlier architecture, they were using a .NET code, right, which is a huge code that they have written. It's more than 1,000 lines of code that they have written to process those events. So we sit with them, we understand what they're doing, and we convert this entire code into the SQL-like queries in the Azure Stream Analytics. All right? I cannot show you the code because that's their IP, but that's what we did over here. Now, once we have the data available, what we do is we process this data and store into the Azure in the Azure SQL Server databases. Okay? Now, we also use blob storage. Now, why did we use blob storage over here? Now, in this case, all the good events which get processed, we send to the Azure SQL. And the events which are bad events, right? For example, if I'm expecting an integer value, but I'm getting non-integer value from the devices itself, I'm going to send this to the blob storage. OK? And what we're going to do is I'll talk about a little later in detail. Now, once we have the data available, then the developer basically uses the Power BI desktop to design the report, which is there on the Azure SQL database. And we use the embedded Power BI to embed the report in their application and send it back onto the various devices, right? Now, this is just the starting of the story. We haven't completed. There are a lot of things that we have did over here. And before that, I'll talk about the flow and the challenges. Now, once we put up this basic architecture in place, we started working with them. And that's the flow that we have followed. We basically setting up their Azure services, configure their gateways to communicate to the IoT hub, build the business logic and stream analytics, design the reports, deploy, and then embed into the report, right? Now, what happens is, when we talking about them, there were some concerns and the challenges that come from the View360 team, right? So one of the challenges, as I mentioned, sending events to the IoT hub, where we are not able to initially send the data to the IoT hub, right? So we cross that. Then we convert the entire .NET code into the ASA queries. Scalability, they don't have to bother about it because they were using platform as a service, your Stream Analytics, IoT Hub, which will take care of the scalability. We also provide the user to ability to scale out themselves with a very easy way, right? For example, in the IoT Hub, you can actually go into the various tiers, S1, S2, S3, and so on and so forth. And then you can, if you want to scale more out, you can actually do the sharding over there, right? With the Azure Stream Analytics, what you can do is you can actually go ahead and increase the streaming units, right? And at the end, there were lots of data that is coming in, right? So what we can do with this data, right? That's another question that come across. And the database optimization, now, which is very important because they are getting a lot of data into the couple of databases that they have set up in their environment. And they basically providing a DTUs. It's kind of a resources for each databases, right? So let's say they have 3 databases, 1, 2, 3. And the one database is using 10% of resources. The another one is 20%. And the third one is using more than 90% of resources. Then they have to provide more DTUs, more resource power to this particular database, right? Because it's consuming more resources. But if you look into this particular picture, the other 2 databases that we have over here, they are not using the full resources at that particular time, right? So what we can do is we basically actually put on a mechanism so that we can actually leverage the resources which is not used on the another databases over here, right? Which will also save the cost as well. And that's where this entire architecture now comes into the picture, what we did with them, right? So some part of it you understand. So let me just go ahead and talk from the Stream Analytics. Now, Stream Analytics has the ability to send the output to the multiple destinations, right? So we have the various connectors available, which you can use. So one of the options that we are using is from the stream analytics, we are sending the alerts to the end user. Based on the threshold that has been defined, what we do is we send that event to the event hub, and Azure Functions, which is our microservices and serverless architecture, is keep talking to the event hub, seeing whether any new event is coming up. Now, as soon as it gets an event, it basically sends that information back to the user's mobile. Okay? Now, before I come to the predictive analytics, let me just talk about the databases output. The process events goes into the database, and as you can see, we put up a elastic pool over here. We configure the eDTUs. So based on the consumptions, based on the network load onto a particular databases, the resources will go up and down, right? Now, then what we did is we basically set up our data archiving policies, because all the data is not required all the time to sit in the database, right? So what we are doing is the data which is not required, we extract down this data, and through the data factory, we are sending into the blob storage. So now your blob storage will have two different containers over there. One is storing the bad events, the other was storing the archival data, okay? All right. Now, we are using the correct data or the right data to building our predictive models using Azure Machine Learning. And with that, the one output goes back to the user. If they want to interact with the machine learning models through the APIs, they can actually go and do that. And at the same time, the Azure Stream Analytics has the capabilities to actually talk to the Azure Machine Learning and then predict in the real time if something is going to happen with your devices or your factory or, or the machines that's running on the factory, right? So I can actually go ahead and configure as an endpoints for the machine learning, use as a function within the stream analytics. So any events that are coming up, it will go to the machine learning, say, hey, here's the event. Can you just tell me what is the prediction you think? So when I get back the prediction, I basically send that information, right? Now the bad data, right? So for bad data, what we're doing is we're basically using the batch analytics over here, using the SD Insight, right? And there are various kind of analytics that we are doing. So for example, they're basically figuring it out, how many bad events that they are getting over a period of time. What are the devices who are keep sending at a regular interval the bad events, right? So all these analytics they are doing, right? And then so that they can go back to the OEM and says maybe this particular device requires some maintenance, or let's figure it out why it's sending too much of bad events, right? Now once it's done over here, then we have the Power BI embedded Power BI, which I heard is a little bit of change is going to happen over here. So probably you want to aware of that. And that's all this information we send it into the devices, right? Be it a mobile device or be it in a web browser. Now with that, let me just go ahead and go back to my machine. And OK, show you some data over here. I'm not sure where this. So this is a test data. So you can assume this data is basically coming from the stream analytics, right? Now, once we have this data, they're basically running some queries to perform various calculations, right? So for example, over here you can see this particular query is display the duration of energy meter for how many minutes it's on and how many minutes it's off, right? Now, this part, earlier they have written into the Visual Studio Code, right? So what they do is they basically have a stored procedure which basically generates the data for a defined period, right? For a day, for a week, and a month, right? And store into the database. So whenever a user is requiring the report for a particular defined period, which is there in the database, they basically takes this data and show it to the user. However, if the data is not available for the defined period, what they do is they basically run the .NET code, and then user has to wait till it gets, calculation gets completed. So we convert this entire Visual Studio .NET code into the SQL query, right? And as you can see, you can actually go ahead and send the time and the device for which you're looking for this information. And at the result, it basically gives you the information for how long this energy meter is on and for how long this energy meter is off, right? And the another critical analytics that they were doing is they're basically tracking how long their diesel generator is running, right? So here's the query, which basically tells them for how long the generator is running. So there's two things that they basically figured out with that. They basically figured out, if the fuel is getting stale or not, right? Because now they can actually see, one day, how long the generator is up and running, right? And they can actually cross-check how many diesel was there into the generator, right? Now, if the diesel is low, then somebody might be stale, so they can take an action on that, right? And they can actually look into how their machines or the generators are performing based on, they have the fuel available, and then they have the running times available as well with them, right? The other thing that they have is, I was talking about sending a event. So let me do one thing is, so remember, I have showed you for SMS alerts, we are using Events Hub and we are using the Azure functions, right? So what I'm going to do is I'll walk you through real quick over here, and I'll go to my function over here. Let me just go ahead and zoom in, right? So let's get into the integrate section of Azure functions, right? So here you can see, I basically set up my triggers on the Azure Event Hub. And what I did is then I'm sending this into the output, which is I'm using a Twilio controller to send the SMSs to the user, right? So that's the configuration that I've did. So now what's happening is my function is sitting and listening onto this particular Event Hub. And as soon as the events will come onto the Event Hub, it will trigger a message to me, right? So let me just go and show the code over here. And in the meantime, let me check if it is running. OK. So here's my code that I have written. And you can see just 3 or 4 lines of code. You can customize the message the way you want. And what it does is it basically takes an object of the output that we have configured. And then it set up the body to whom you want to send the message and the message string. And then it'll go off, right? So let me just go ahead and test over here. And so I can actually go ahead and test from the portal itself. Let me just expand the logs, right? And let me just, so once I click on run, as you can see in the bottom, it just sent in a message, right? It sent in a message to the mobile device. Now it sent the message to me, but since I'm on in the roaming, my number is not active. But I'll show you how it's going to look like when the user receives this message. I have my device over here. And let me just go ahead and unlock this. Right, so I can send the message from here as well, from my device. But nevertheless, here you go. Right? So as soon as the message comes in, it'll get into my phone itself. And then I can actually go ahead and take a action accordingly. Right? Yep. So at the last, real quick, there are some resources for you guys. So if you want to look into the more information about these case studies, we put up these case studies. You can go through these links. If you want to know how you can use those commands to send message to the IoT hub from your SIMCOM controllers, you can actually go into this, look into the GitHub. And there's IoT security best practices available in case if you want to look into that. Right? So with that, thank you very much for listening in. I hope it will helpful for you guys. If you have any questions, I'll be here around, and I'll be more than happy to answer you. Thank you very much.